In this video, we're going to learn about the unit circle. So we've seen when you want to find sine, cosine, tangent, and so on for a given triangle, we have our SOHCAHTOA, and then we can take reciprocals. So we know how to find those for given angles, but what the unit circle allows us to do is allows us to make our lives a little bit easier here, because if I draw a triangle like this, or if I draw a triangle like this, or if I draw a triangle down here, or in the fourth quadrant. Thing is, that's not a very good triangle there, but regardless, any of these triangles, I know something about the hypotenuse. In every case here, the hypotenuse is a radius of the circle. And so what that means is that the radius is always 1. That's why it's called a unit circle here. And that means that the hypotenuse is always 1. And so when I try to do opposite over adjacent or opposite of hypotenuse, so on, I know my hypotenuse is always 1 here. And so if I look at any particular random point, say x, y, on my unit circle, and I draw my angle here, and I call this theta, then based on how things work, the x tells you how far to the right you went, so x is how long this side is. Y tells you how much you went up, so y is this side. The hypotenuse is 1, and so that means that my sine theta, opposite of our hypotenuse is y, cosine theta is adjacent over hypotenuse is x, and tangent theta is going to be y over x, and then you have your three reciprocals, right? And so what this does is it tells us that if we look at our unit circle and we look at any point here, the x coordinate tells you your cosine, the y coordinate tells you your sine, and if you take the ratio of those two numbers, it tells you your tangent. So it's great. We get the information we need here. And so if I ever give you a unit circle and I draw any particular point in the circle, I'll give the coordinates, that automatically tells you your sine, cosine, and your tangent. But then furthermore, we really want to know all of our special angles on here, and there's going to be a lot of them. And I'll go ahead and mark them here. And you're going to want to know all of these and their actual values. I'd recommend memorizing it in some way. I will say that the way I learned these was that the way my teacher did was they gave us a quiz every single day, and the quiz was to fill out this entire chart here. And every time we took the quiz, we had less time. So we had 15, 20 minutes the first time, and then 10 minutes, and then maybe 5 minutes, and you got it down to where you had to complete the whole thing in 1 minute. And by repetition, we were able to do that. And really, it does actually help quite a bit to memorize all these values. So this first point is going to be at the 30-degree angle, which is also pi over 6. And the coordinates are going to be root 3 over 2, 1/2. So again, what that means is that the cosine of 30 is root 3 over 2, and the sine of 30 is 1/2. And then the middle point here is going to be the 45-degree angle, and the coordinates there are going to be 1 over root 2, 1 over root 2, or if you prefer, you can write it root 2 over 2, root 2 over 2. And then the third one in the first quadrant is the 60-degree, sorry, this is pi over 4 down here, and 60 degrees is the same as pi over 3 radians, and it's going to be 1/2 root 3 over 2. And one thing you can kind of say is a little pattern here. If you think of this is that, look at the y coordinates of these points. The y coordinates start out at 0, which is the same as root 0 over 2. And then it goes to 1/2, which is the square root of 1 over 2. and then it goes to 1 over root 2, which is the square root of 2 over 2, and then it goes to the square root of 3 over 2, and then lastly it goes to 1, which is the same as square root of 4 over 2. So you can think of it as square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. It's a nice little pattern to remember the numbers there. And as you can see, you're going up the circle, so your y's are increasing those numbers. And on your x's are going to be decreasing through those same numbers there. So it's a little pattern there. Once you get the first quadrant down, the other ones are going to be the same values, but some of them negative. So for example, this is the same height, but it's to the left side, so it's going to be negative 1/2 and positive root 3 over 2. This would be negative 1 over root 2, positive 1 over root 2. And this will be negative root 3 over 2, positive 1/2. And again, these points here, so this is our 90 degree, pi over 2. This would then be 120 degree, which is 2 pi over 3. 135 degrees, which is 3 pi over 4. And then 150 degrees, which is 5 pi over 6. Then we get the straight angle, which is 180 degrees, or pi. Continuing on, this is the same x-coordinate, but now it is down. And this is the same x-coordinate, but now is also down. Same x-coordinate, but now is also down. Similarly, this is going to have the positive x-coordinate, but the same negative coordinate for y. I get the positive and negative, and positive and negative. And again, it's a lot to take in all at once, and really the only way to memorize it is through repetition and practice on these. The angles here would be 210 degrees, which is the same as 7 pi over 6. And then 225 degrees, which is 5 pi over 4. And then 240 degrees, which is, what's it going to be, 4 pi over 3. And then 270 degrees, which is 3 pi over 2. And then 300 degrees, which is the same as 5 pi over 3. And then 315 degrees, which is 7 pi over 4. And then lastly 330 degrees, which is 11 pi over 6. And so once you have this down, then you can find the trig value, sine, cosine, tangent of any of the special angles we may have. And if you have an angle other than these, then you'll just use your calculator to get a decimal approximation for them. And one last thing to mention on this video here is that you can see how, depending on which quadrant you're in, the pluses and minuses switch around there. And there's a fun little thing to remember whether you're going to get positive or negative answers for trig functions. And it's all students take calculus, ASTC. And so A stands for all of them are going to be positive. Sine, cosine, tangent, all three of them are positive in quadrant 1. In quadrant 2, the S stands for sine. So your sine will be positive, but your other ones, your tangent and your cosine, are going to be negative. In quadrant 3, the T stands for tangent. So your tangent is positive, but your sine and cosine are negative. And lastly, the C is cosine. So in quadrant 4, your cosine is positive, but your sine and your tangent are negative.